Welcome to a special 15-year anniversary episode of Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office, or NNCO. Today it's my pleasure to welcome Celia Merzbacher, Assistant Director of the Quantum Economic Development Consortium at SRI International. Prior to joining SRI, Celia was the Director of Strategic and Institutional Planning and the ARPA-E Program Manager at Oak Ridge National Laboratory. She also served as the Vice President for Innovative Partnerships at the Semiconductor Research Corporation, or SRC, and as an Assistant Director for Technology Research and Development at the White House Office of Science and Technology Policy. Celia, thank you so much for taking the time to be with us today. To get things started, could you share a little bit about yourself and how you first got involved in nanotechnology?
Well, thanks, Lisa. It's nice to be with you. When I think back in the 80s and 90s, I was doing a lot of materials research, first as a postdoc at Lawrence Livermore National Lab, and then as a research scientist at the Naval Research Laboratory in Washington, D.C. I was studying the atomic structure of everything from materials proposed for nuclear waste storage and high-temperature superconductors to space-based optics and nanostructured aerogels. And it was really nanomaterials science, only we weren't calling it that. And in 2003, I was recruited to the White House Office of Science and Technology Policy to help lead the new National Nanotechnology Initiative, or NNI, which was really in the early days. And as attention and investments were growing, we had to address issues like environmental health and safety, and public communication and outreach and education and standards, in addition to research. So it was exciting to be working on an emerging area of technology with enormous potential for all kinds of practical application and use and public benefit.
So you're currently the Assistant Director of the Quantum Economic Development Consortium at SRI, which was just launched at the end of last year. So can you tell us a little bit more about this activity?
Well, the QEDC is a consortium aimed at accelerating and strengthening the U.S. commercial quantum information technology industry. It's really a public-private partnership. It has support from industry member companies and from NIST, the National Institute for Standards and Technology. Understanding the quantum properties and behavior of materials and components and systems is the subject of considerable research right now, and government agencies, including NIST and NSF and DOE and DoD and others, are growing their spending in related areas. And at the same time, the private sector is making some really big investments as well. There's a lot of activity going on, both in the publicly funded sector and in the private sector. And the QEDC is going to bring together companies from across what we think of as the quantum supply chain and help identify gaps in enabling technologies that are going to make it possible to realize the benefits of the quantum technologies that are being researched. There's need for standards and performance metrics, and there's a lot of workforce needs that are perhaps in some sense short-term because eventually there will be a lot more students graduating, but right now there's a real shortage of skilled workers in the space. So these are all areas that the consortium is going to help to address. And once these gaps are identified, then that consortium can figure out ways to help solve them.
With your background in nanotechnology and now moving into quantum information science, how does nanotechnology enable quantum information science?
Well, in a lot of ways, quantum information science and technology feels like nano did 15 years ago. There's a lot of excitement in the research community, and there's a lot of well-attended conferences going on and publications being made. And at the same time, there's a lot of hype in the business sector. And on the other hand, people who aren't perhaps in the middle of it, policymakers and the public, have trouble even understanding what it's about. And so the QEDC really needs to, in order to accomplish its mission, do more than just help advance the technology, but it also needs to communicate to various stakeholders about the potential and help businesses who may not have expertise to understand how it could help them do their business. Now, there's a significant overlap between quantum information science and technology and nanotechnology because nano, I think of as being the fundamental understanding of materials at sort of the level of atoms and molecules. And that fundamental understanding is going to be essential to progress in quantum information science and technology. It's really key to understanding what is going on that is controlling the development of materials for quantum devices, controlling system noise, which is sort of underlying a lot of the challenges to quantum computing, integrating quantum devices with what we think of as classical or traditional technologies and networks and so on. So there's a real sort of adjacency and even overlap between nanotechnology and quantum information science and technology. I see quantum information science and technology as a convergent area with underneath it nanotechnology advances being important, networking and computing, and areas like optoelectronics and optophotonics. And each of those areas in and of themselves are multidisciplinary, made up of physics and chemistry and materials and engineering. So I think that this is just another example of where the leading edge of science and technology involves the convergence of a lot of existing areas of research.
Well, it sounds like a lot of fun. Reflecting, though, on the NNI, and part of this podcast series is to celebrate some of the activities or accomplishments that have been made since the law was signed in 2003. So, from your perspective, what are the things that really strike you or stand out to you?
So, looking back, I think that nanotechnology has gone from being kind of what I think of as a buzzword to being reality. And I remember early on worrying that there was going to be some backlash because of some concern that grew and was hard to address, perhaps, and sort of like the GMO concerns impacted that area of development, that we thought something similar might happen. And it was part of the reason that there was activity and investment from the very beginning in understanding potential for risks and understanding interactions between nanomaterials and the environment and the body. And so I think that over the years, that course, that approach has really been a hallmark of the nanotechnology program and also has been part of the reason for its success and the fact that the science was able to sort of progress and lead and follow toward the benefits that everybody was hoping for at the outset. I think on the commercial side, there's really less concern about whether something's nanotechnology or not. The ability to control and operate at the nano scale is being incorporated in a lot of different ways in products and processes by business. They may or may not think of it as nanotechnology at all. So I like to say there's not really a nano stock index necessarily, but many of the big companies that are very successful are using nanotechnology today, thanks to the NNI.
One of the things that we hear a lot is that the collaborative environment, the ecosystem, the multidisciplinarity that was developed under the NNI made it different than the way science was done before. Do you have thoughts on that?
I agree 100%. I think that, and I give credit really to one of the founders of the initiative, Mike Rocco, who was a really very visionary and broad thinker. So, by design, the people who started the program saw nanotechnology as multidisciplinary and therefore cutting across all kinds of boundaries. And whether that meant divisions within funding agencies or departments at universities or offices within professional societies and scientific organizations. Nanotechnology didn't just fit simply and neatly into any one area. And so it forced the bureaucracies and the cultures of those organizations to change. And I think that in some ways is one of the biggest impacts of nanotechnology to this day. And not only do faculty continue to do multidisciplinary team-based research, but the students who were there, learning and growing up in that environment don't know another way in a sense. And so they've graduated now and they think that's the only way to do things in a sense. So I think that that was one of the big impacts of the nanotechnology program.
I think that from the NNI perspective, although there's been nano-enabled products on the market for decades, we're really seeing a transition in mass applications of nanotechnology, in automotive and flat screen TVs with quantum dots and other breakthroughs that are hitting commercial markets but can be traced back to research from the late 1980s. You're mentioning that industry is already making significant investments in quantum. And of course, quantum science has been a topic of study for decades as well. Do you see that it's really ready for broad commercial applications?
I think a lot of times when people hear quantum, they think of quantum computing, which is probably the longer time horizon application, versus you could make the case that there are applications of quantum phenomena like atomic clocks and things like that today. And so there is a spectrum. And I do think that it's very appropriate, in a sense, for the government to be shooting for that longer term advance and technology development, if you will. Along the way, just like the Apollo program, there's going to be spin-offs, I think, in a lot of different areas. And so whether it's sensing or communication or simulation and modeling, and there's just a lot of different applications of the understanding of quantum behavior and the ability to control it. And there's right now it does have a bit of the Wild West feeling, and there are a lot of different strategies being developed and championed. So again, some of those may prove out to be very general in their applications. Some may be more niche and be really well suited for particular areas and particular applications. We've been sort of spoiled by Moore's law and the ability for this one single technology to advance over decades and orders of magnitude. That may not be the model for the technologies of the future.
So, speaking of beyond Moore's Law, I actually wanted to ask a question about your time at SRC and the Nanoelectronics Research Initiative, which was a collaboration between SRC and NIST and NSF, where the academics were looking at beyond CMOS or new technologies that would advance past the end of Moore's Law. What do you think are the lessons learned from that public-private partnership?
I am a huge fan of the NRI model where the needs of industry and the leading edge research are aligned to the point where it really makes sense for this co-investment in that fundamental research that industry will take and use as it sort of sees fit. In the case of nanoelectronics, the industry was extremely farsighted in making investments in the potential disruptive technology to their own business in a sense, but they also recognize that in order to continue the sort of part of Moore's law that was the performance trend, forget about the size and the scaling and shrinking and so on, but just that trend in performance, they were going to have to make a step to new technologies at some point in the future. And so investing early on was what they felt was, important seeds to that future, their own sort of self-interested investment. At the same time, that model allows not only for industry to have some sort of influence on the investment of research dollars, but almost as important or more important, it gives them contact in a sense with faculty and students. And I always felt that through the personal interactions that took place between industry experts and the academics, both the faculty and the students, there was a real enhancement of the research and of the educational experience that the students had while they were in the middle of their university years. So at the end, they may or may not choose to go into industry, but they've had this exposure. They will always be thinking about the sort of ultimate use of their research, I think, because of that experience. So I think there is huge value to the educational process through that kind of partnership. And I certainly hope and will bring that lesson to the Quantum Consortium as well.
That's great. So I want to look forward. Can you comment on where you see challenges facing the world that may be solved in part by nanotechnology?
I think I have sort of sometimes a simplistic way of thinking about science and technology, and I see the sort of push aspect of it and the advances through the investment in basic scientific research that creates something that could be applied and help solve a problem. And then you have the pull kind of aspect where a real problem is posed and the science and research community thinks about what kind of research might it do to address that problem and to solve that, or to take its sort of toolbox of solutions and put them together in some useful way that would solve a problem. So I can almost not think of a problem in the world that isn't potentially tackled by a nano solution. And I think that it's really important, and the NNI has been doing this for some time, to articulate those challenges in such a way that the research community can roll up its sleeves and really, start tackling those problems. So the priorities of any particular administration, or, if you look out at the world, those are going to maybe at a very high level be common: public health and clean water and energy for all that's affordable and so on. These are problems that are going to be with us forever, in a sense. Trying to put them in sort of the hands of the scientists in a way that they can make some move towards solving them, I think, is often the challenge. And that's where agencies that have a mission, like DOE and so on, NIH and others, I think have a role to play in connecting those societal challenges to their research communities.
I just want to tell you how much I've enjoyed our conversation today, and I thank you for taking the time to talk with us. And I'm wondering, do you have any parting thoughts that you want to leave with our listeners?
So I just want to thank you also for the opportunity. I see a sort of Moore's law of nanotechnology, the ability to control and measure matter at always more precise and higher resolution capabilities, and in areas where in one time or another it was almost impossible. Biological materials posed a lot of challenges to these kinds of nanoscale controls, but those are being overcome. So I see nanotechnology as continuing to enable new capabilities and the potential to address all of the kinds of challenges that we discussed. So I'll sort of wrap up with a paraphrase of Richard Feynman's: "There's still plenty of room at the bottom," and I think that's true for many years to come.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov, and check back here for more stories.